For this video, the group will discuss all about concrete. For this first part though, we will discuss a little recap, a little review, a short review about whatever we've discussed and experimented on lastings, construction materials, and testing. To start, concrete is strong in compression but weak in tension. The tensile strength is generally rated about 10% of the compression strength. For this reason, concrete works well for columns and posts that are compression members in a structure. But when it is used for tension members such as beams, girders, foundation walls, or floors, concrete must be reinforced to attain the necessary tension strength. Its advantages include lower life cycle cost, moldability, robustness, and can be designed for desired property by changing proportions of ingredients. We've discussed that last term on how to design your mix through specifications, of course. Its disadvantages would specifically include, obviously, low tensile strength and low ductility, meaning it is brittle. Moving on, we can go now to the history of concrete. The history of concrete will start off 2000 BC, where Egyptians used cement in mortar when making pyramids. That's cement. Then later on, 27 BC, Roman cement made of lime and volcanic ash was used. Next, we go to the English. In 1756, John Smithson rebuilt Eddystone Lighthouse. This lighthouse is actually a product of trial and error. The first lighthouse was made out of timber, the second oak and iron, and then on the third, John Smithson revolutionized the construction of such towers made entirely by interlocking stone. It stood there until it was replaced 123 years later by Sir James N. Douglas, which now rises 40 meters above water. Then, in 1824, Joseph Aspdin, another Englishman, discovered and patented Portland cement. Since that time, a number of developments and improvements have been made in the production process and cement properties. Cement is a material having cohesive and adhesive properties which provides bonding action to other concrete ingredients. It is the most important ingredient of concrete, and that was patented by Joseph Aspdin. We go now to what makes up concrete. Concrete is basically made out of cement, water, and the aggregates, fine and coarse. Cement has been discussed earlier a while back. Now, water used in concrete must be clean. Para sa tanong na kung pwede bang gamitin ang ihi sa pagdedesign ng mix, kung yun yung pwedeng tubig mo sa konkreto, hindi siya. A rule of thumb in the concrete industry is that if the water is fit for drinking, it is fit for use in concrete. Because seawater contains salt, its use leads to corrosion of reinforcing steel. So clean water is really the best. For given materials, the strength of the concrete, so long as we have plastic mix, depends solely on the relative quantity of water as compared with the cement, regardless of mix or size and grading of the aggregate. To prove this fact, where water and cement ratio is a must, we have this video to show you just the right consistency of our concrete mix. Too wet, too much water, meaning too much water. And then this is to dry. Kung tatansya-tansyahin ang tubig, kailangan ganyan ang itsura ng concrete mix natin. Some would even describe that as the texture of a cookie dough. Now, let's go to the aggregates. For the question, we have these types of aggregates. Coarse, specifically, we have flat, elongated, angular, and round. The best type of coarse aggregate that's been said is neither this one, neither this nor this one. The best, they've said, is the round aggregate. Rounded aggregates are suitable to use in concrete because flaky and elongated particles reduce workability, increase water demand, and reduce strength. In the case of angular particles, the bond between aggregate particles is higher due to interlocking, but due to higher surface area, angular particles increase water demand and therefore reduce workability. And that is it for the part 1 of the report for concrete.
In continuation, concrete is strong in compression but weak in tension. For this reason, it works well in columns and posts. When used for tension members such as beams, foundation walls, or wall concrete, it must be reinforced to attain necessary tension strength. According to American Society for Testing and Materials, there are 5 basic types of cement. Type 1 is used for general construction purposes. It is also called ordinary Portland cement. It is used for bridges, buildings, and precast construction. Type 2 is moderate sulfate resisting cement. It is used for structures in water or soil containing moderate amounts of sulfate or when heat buildup is concerned. It is used for substructure or for foundation and basement walls. Type 3 is used when high strength are desired at very early period. It is useful during cold weather concreting where quick strength gain is a factor. It produces more heat than type 1. Type 4 is used where the amount and rate of heat generation must be kept to a minimum. It produces less heat during the hydration process, thus useful for hot weather concreting. It is useful for producing large quantity of concrete, which is meant for massive structures such as dams. Due to its limited use, it is produced by manufacturers only on special requests. Type 5 is a type of cement used where there is a possibility to contact high sulfate with concrete. When soil and groundwater are tested with high sulfate content, type 5 is used. The rate of hydration for this type of cement is slower than type 1. Other than this, types 1A, 2A, and 3A are cement used to make air-entrained concrete. They have the same properties as types 1, 2, and 3, except that they have small quantities of air-entrained materials combined with them. When mixing up concrete, water is essential. Water must be clean because, for example, seawater contains salt, which may lead to corrosion of reinforcing steel. Water-cement ratio. Water-cement ratio is the weight of water and the weight of concrete used in a concrete mix. A water-cement ratio of 0.4 means that for every 100 pounds of cement used in concrete, 40 pounds of water is added. The normal water-cement ratio used in ordinary concrete for sidewalks and driveways ranges from 0.6 to 0.7. Slump test is a test used to measure the consistency of fresh concrete before it sets. The word slump is simply a term coined to describe how consistent a concrete sample is. It determines the workability of concrete, how easy it is to handle, compact, and cure concrete. The properties of concrete will be discussed by Judge Avanzado.
Properties of concrete. Number 1. Grades of concrete. Concrete is known by its grade, which is designated as M15, M20, etc., in which letter M refers to concrete mix and number 15, 20 denotes its specified compressive strength or 150 mm cube at 28 days, expressed in Newton per millimeter squared. This is the different grades of concrete and their applications. Compressive strength of concrete. Like load, the strength of the concrete is also a quality which varies considerably for the same concrete mix. These are the different compressive strength of concrete at various ages. Next one, the characteristic strength of concrete. It is defined as the value of the strength below which not more than 5% of the test results are expected to fall. Tensile strength of concrete. The estimate of flexural strength concrete or the modulus of fracture or the cracking strength of concrete from cube compressive strength is obtained by relations FCR equals 0.7 FCK Newton per millimeter squared. The tensile strength of concrete in direct tension is obtained experimentally by split cylinder. It varies between 1/8 to 1/2 of cube compressive strength. Creep and concrete. Creep is defined as plastic deformation under sustained load. Creep strain depends primarily on the duration of sustained loading. The value of the ultimate creep coefficient is taken as 1.6 at 28 days of loading. These are the examples of creep in concrete, these two pictures. Shrinkage of concrete. The property of diminishing volume during the process of drying and hardening is termed shrinkage. If this strain is prevented, it produces tensile stress in the concrete and hence concrete developed cracks. Modular ratio. Modular ratio is the modulus of elasticity of steel to the modulus of elasticity of concrete. Poisson's ratio varies between 0.1 for high-strength concrete and 0.2 for weak mixes. It is normally taken as 0.15 for strength design and 0.2 for serviceability criteria. Next, durability of concrete. It is the ability to resist in disintegration and decay. One of the chief characteristics influencing durability of concrete is its permeability to increase of water and other potentially deleterious materials. Last one, unit weight of concrete. It depends on percentage of reinforcement, type of aggregate, amount of force. It varies from 23 to 26 kilonewton meters squared. Here are the common concrete problems. There are 4 common concrete problems illustrated here in the PowerPoint presentation. Number 1, cracking. As concrete is curing, it naturally shrinks, and this shrinkage may cause cracking outside the intentionally placed joints. The concrete is still structurally sound and still considered quality material. Next, scaling or spalling. It occurs when parts of the concrete surface start to flake or chip away. This is usually the result of water seepage, freeze-thaw, poor concrete finishing, or a weak surface due to lack of curing. Typically, this will start in one area of the concrete, but if left untreated, it can expand to other areas. Discoloration. It can occur for a variety of reasons such as weather conditions, material exposure, and even curing time. Grazing. It refers to a network of fine cracks that do not extend below the surface. It is more of a cosmetic issue than a structural issue, which means that even if it has grazing, the concrete is still sound. These are the examples of the common concrete problems. These will Number 1 is the cracking. The next one is spalling or scaling. And this is the discoloration. And this is the crazing. The difference between cracking and crazing is cracking, it does not extend, but crazing, crazing does extend below the surface, but cracking only on above the surface.
Hello? So, good afternoon. Yung report ko about solutions sa mga problems na na-encounter natin sa concrete. So, yung mga common problems is once again cracking, scaling, and yung discoloration, crazing. Actually, meron pang isang topic, yung bleeding na which is later explain ko din. So, ano bang pwedeng solution sa discoloration? Well, dito sa discoloration, bago pa natin siya ayusin, pwede na natin siya i-prevent. Like for example, wag natin hahayaang mag-evaporate bago tayo mag-finish. So kung kapag puro alam nating matubig talaga yung ginawa nating mix, may make sure natin na matutuyo muna siya bago natin i-finish. Second, avoid hard troweling on the exterior surface. So, hindi na siya pwedeng malakasang i-trowel kapag i-finish na natin. Kasi ang mangyayari, magkakaroon ng discoloration throughout time. Also, in case na mangyayari yun, gagawin natin, flush and scrub. Pag flush and scrub, well, typically, linisin mo lang siya, tapos hugasan mo, ganun lang gagawin. Sunod yung acid wash. Ito yung mga medyo much advanced na ginagawa para ma-dissolve yung coloration na kung saan gumagamit na sila ng acid, well, typically muriatic acid. Tapos, lastly is yung tinted sealer. Ito yung mga makabagong technology. Ang ginagawa na nila, may mga sealer na nilalagay para pumuti, luminis yun. Next, crazing. Yung crazing, lang yan, maraming cracks. So, pag sinabi mong crazing, consist of many cracks. So, bago natin isolve yan, isolve na lang muna natin yung cracking. Kasi pag na-solve mo yung cracking, ma-resolve mo yung crazing na problem. So, dito, cracking of concrete isn't necessarily bad. Small cracks will do just fine. Since compressive force lang hinihingi natin kay concrete, pero there are some cases na iwasan natin tong mga cracks na to, lalo na kapag nasa beam, diba? So, mangyayari dun, avoid excessive cracks or excessive deflection. So, ngayon, yung dito naman, kadalasan sa cracking, mga excess water. Ang ginagawa nandito ng mga sa new technology, mga epoxies. Ewan ko napapanood niyo sa video, pero meron tayong mga epoxies for crack injections. So, if taken lightly, it might jeopardize the entire integrity of structure. So, pag nasolve mo yung mga cracking ng concrete, masolve mo yung crazing. Next, scaling. Kadalasan dito scaling parang may patch kung tawagin, parang nare-remove siya. Main common problem dito is too much water. Well, doon naman talaga yun naman talaga yung focus para hindi para hindi madalas yung scaling. Also, sa scaling, ang iiwasan natin doon, kapag nag-finish na, nilalagyan pa ng wisik-wisik na water. Nakikita niyo sa mga construction worker. And yung parang tinatapon-tapunan nila ng cement. So, nangyayari, nagkakaroon ng mas makapal na content ng cement yung isang part kasi parang pinipitik-pitikan lang nila. Do not sprinkle water, gaya nga sinabi ko kanina. And same with discoloration about evaporation. Next, reinforced concrete. So, sa reinforced concrete, actually, hindi na sa akin to, pero kasama dun siya sa PowerPoint ni Sir. Concrete reinforced with steel is the foundation of our modern society. Reinforcement within concrete creates a composite material with the concrete providing strength against compressive stress, while the reinforcement provides strength against tensile stress. So, ano ba ibig sabihin nun? Yung reinforced concrete, ito lang siya. Ang tawag dyan, rebar. para lang siyang pampatibay sa concrete kasi hindi naman makakastand yung concrete nang mag-isa lang siya. Tandaan natin na ang turo sa mechanics, yung concrete malakas siya sa compressive strength pero mahina sa tension. Okay? Kaya andun yung rebar o yung bakal para tulungan siya. So ito yung sample ng reinforced concrete na binasag. Pero since ibang topic na yan, that's it. What the important thing for you to be a reminder, no?